Hi, today is day 6 of Unit 5, Graphing Functions. Before we go into today's lesson, I just wanted to go over the, really an exit ticket. I gave it to you at the end of class. I accidentally wrote bell ringer on it. But anyways, so for this one, I just wanted to go over the answers in case you were still struggling with piecewise functions. So for the first one, we have f of x is equal to the function x if x is greater than 0 or equal to 0, and then f of x is equal to x minus 2 if x is less than 0. So just to refresh you guys on how we do our piecewise functions is the first thing. Remember, piecewise means that we have multiple functions and we're putting them together. And then we give you specific parameters based on the domain. Okay, so for this one we have x is greater than or equal to 0. So I'm only going to use values that are greater than or equal to 0. Then for the second function, I'm going to use x less than 0. Now the important thing is you still have to graph 0, but remember that it's going to be an open dot instead of being a filled one like for this function over here. So I didn't ask you to make these tables, but I do think that it is much easier if you do. You can map out if it's going to have an arrow, you can map out the open and closed dots, you can figure out which direction they're going. It just really makes it a lot easier for you, and I think you'll get more points, and it just will make more sense if you do it this way. So going to the right, that is my f of x is equal to x. Now notice I just wrote f of x at the top. If you label both of these, so f of x equals x and f of x equals x minus 2, that's not technically right because remember these functions, if we didn't have these parameters of the domains, they're not going to go on forever to infinity like the normal functions. We've restricted them. We only want that function from 0 and on, positively. And then vice versa for the function x minus 2. We don't want the whole function. We just want all of the function when x is less than 0. So hopefully that makes more sense after those two previous lessons. Okay. Number 2 is a little bit tricky, mostly because number 1, there should have been no arrows. Now let me explain that. So if you notice, the parameters that they gave you are very, very specific. Okay, they only go from 0 to 3. 0 is included and 3 is not included. So that would be an open dot. Okay, and that's for the function 2x plus 3. So again, I went from 0 to 3, and I kind of mapped this out before I even put it onto my graph. So I know that at 0, 3, because x is 0 and we have the less than or equal to sign, I know that that's going to be a filled-in circle. So that's going to be closed dot. Now at 3, that does not have an equal to sign, so that one is actually going to be open. So I've mapped it out for you. We need just the numbers 0 through 3. We do not go any further, okay, because they specified we only want from 0 to 3. So I found all of those coordinates, and then I graphed them, okay? And I do not put any arrows because it does not go past any of these points. Similarly for x minus 3, now this has even less points. So I have negative 2 to 0. Remember, the smallest number is always going to go on the left side, and then the largest goes on the right side. So I'm actually going to, and you could have done negative 1 down to 0, doesn't really matter the order, as long as the y values correspond. So this one actually only has 3 points that we're going to, of course, on this little line segment there is going to be infinitely many points, but the ones that we can graph with our naked eye, there's only going to be 3. And at 0, negative 3, and at negative 2, negative 5. Those are going to be open dots. So please be careful when you guys are drawing your open dots. They really need to go right around, like even I could have done a better job at drawing that circle, but they need to really go right around that point. Don't just, draw a big open circle and call it a day. it's got to be around that coordinate. So just make sure that you do that. Okay, so for today's lesson, again, day 6 of Unit 5, we're going to learn how to graph step functions. So step functions, the reason why I do it right after piecewise functions is step functions are kind of a type of piecewise function, but the thing to remember is that it should resemble, so the graph should resemble, one second, it should resemble like stair steps. Good color. So stair steps. And that's why it's called a step function. So for a piecewise function, that's usually going to be like straight lines or absolute values, or eventually we'll do quadratics, which is going to be a parabola. So as it increases or decreases abruptly from one constant to another. Okay, so what we're going to do is the biggest thing to notice with our step functions is we have to make sure that we really recognize our domains, because remember, if you have 2 points that are closed and they are vertically above each other, that's not going to work out for you. Okay, so these are all going to be closed and these will be open, and that will make more sense as we go through. Okay, so we have f of x is equal to -2. F of x is equal to -4, and f of x is equal to -6. Okay, so these are all going to be perfect horizontal lines. So now what I'm going to do is I'm actually just going to really quickly go through. So this -2, that one just goes from 0 all the way to 2. The second one goes from 2 to 4. And then the third one goes from 4 to 6. So we're actually only going to plot those points. Okay, so 3, 4, and then 4, 5, 6. Now if you need to put these in your calculator, go ahead, but I'm hoping that you know all of these are just going to have the same function answer. So if f of x is equal to -2, then all of those y values are -2. Because remember, these are going to be all horizontal lines. Okay. So you'll see what I mean by a step function. So let's do f of x is equal to -2 first. So we go to 0, -2. I'm going to do a closed dot right there, and then again we go and then this one is going to have an open circle. Okay, and boom. Alright, now we're going to go to -4, so we go down 2 spaces. Now this one is going to be closed. Come on. Okay, and then at 4 it's going to be an open dot. There we go. And then at -6, at when x equals 4, that's going to be a closed dot, and then open at -6. Okay, so and just to kind of show you a better, a little cleaner example. Okay, that's what your function should look like. Okay. All right. Let's do the next one. Okay, so again, I'm going to break up all these functions, and then I'm going to just write their domains. So now we have this side is all going to be open, and this side will be and that is what your step function would look like. Okay, so again, I used my parameters, my domain, and these only have 2 coordinates. Okay, so that's why I showed you. I did by hand, just so you can see. So when f of x is equal to 1, these each just have 2 coordinates. Okay, so we're doing 0 to 1, and then 1 to 2, 2, 3, 3, 4. So those are my x values, and then again, these are all going to be horizontal lines. So I'm hoping that you see that these are like steps going up. So that means that for the range, all right, the range is exactly like it has here. So it's only going to be at 1, at 3, at 4, at 6. Those are going to be the only. So in between these 2 steps, there is no function. Okay, so it's not a straight line. We don't connect these lines or anything. This is how our steps go. Okay. I don't know that that looks right. Let me double check that. I'm going to draw that myself, actually. Okay, so let's see. So that would be an open circle right here, and then closed, and then open and close. Oh, I probably shouldn't use pencil. That doesn't look good. Okay, so open and closed and connect. Open, closed, and connect. Okay, so we're doing a little step. So there is a little line in between these 2 coordinates. Okay. Oh no, that one is right. Yeah, that one looks good. Thought it was going up by 2s, but it goes 1, 3, and then 4, and then 6. Alright, that's good. Alright, so for this last one, we have a word problem. That would be important to go over, a word problem. So let's break the word problem down first. So a school will charter buses so that students can attend a football game. Each bus can hold a maximum of 60 students. Make a graph that models the relationship. Okay, so it tells us that the number of students, number of students is x, and number of buses is y. So I'm going to write number of students, and then number thought I could write sideways, but I can't. Number of buses. Okay, so I'm going to make, so again, make sure you label this. Okay, so I'm going to make each of these worth 1. Okay. And I'm going to make each of these lines worth 60. So 60, 20. I'm going to skip every 2 just because I can't really write that skinny. Okay, so again, each line is going to be worth 60. So 60, that'd be 120, so I'll go to 180 here, 240, so I'll go to 300 right here, 360, and then 420. Alright, and I'll stop there. Okay, so it's saying that each bus can hold a maximum of 60 students. So first we'll draw a little dot at 0, 0. Okay. So 0 buses, 4 0 students. Okay. All Alright, so I'm going to do an open dot on the 0 here, and then it'll be a closed dot right there. If I jump up to 2 buses, we would have an open dot, and then it would go to 120. If we had 3 buses, okay, so this is a good representation of a step function, okay, because we can't have 1.5 buses, right? We can only have whole number buses. We wouldn't jump up to the 5th bus unless we had, let's see, like 241 students. So it'd be right after that one. So that's why that's step function. All right, and you get the gist. So just to kind of explain what that is. Oh, that's far too much. So basically all that happens is the number of buses goes up by 1 every time the number of students exceeds a multiple of 60. Alright, so now that you're done with that for your classwork, I want you to do questions number 4 and 5. For question number 4, you can use examples 1 and 2. Or, I won't say examples. And then for number 5, use example number 3. So just to show you, so a maximum of 10 people. So Zach is setting up a seating chart for his bar mitzvah. Help make a graph that models the relationship between the number of people, which goes on the x-axis, and the number of tables, which goes on the y-axis. So we're only going up to 10 people. So that is going to be from 0, like that. From 0 all the way to all the way to 10. So that's the range. And then at each one, you can have 10 people. So obviously at 0, you'd have 0 people. At 1, you'd have 10 people, and so on. Okay?